Hi, welcome to the dynamics tutorials. So with this problem we have projectile motion, which is an application of the curvilinear motion. And so this problem we have a particle that's resting on the ground over here. We're going to give it an initial unknown velocity at an angle of 40 degrees to the horizontal. And then it needs to just clear this 3-meter high wall that's located 10 meters over. So we can start off looking at our x motion first. So our x equation is going to be x is equal to x naught plus v naught in the x direction, so our initial velocity in the x direction times time. So this will be the 10 meters when the particle is here is equal to the 0 meters when the particle's in the initial position plus v naught cosine of 40 degrees because the 40 degrees is adjacent to the horizontal component of the plane here, times the time here t. So just rearranging, we get that v naught is equal to 10 meters divided by cosine of 40 t, and so v naught is equal to 13.05 meters divided by time. Then we can look at the y component of the velocity. So we have our y is equal to y naught plus v naught in the y direction times t minus 1/2 gravity times time squared. Acceleration due to gravity, times time squared. So now plugging in our y values, our particle is going to be here at the top of the wall, so 3 meters. We started here at the bottom of the wall, 0 meters, and y times v naught sine of 40, that'll give us the y component of the initial velocity, times time minus the 1/2 9.81 meters per second squared times time squared. And then now we'll plug in our expression here for v naught. So in place of the v naught, we have 13.05 meters divided by time times sine of 40 times time. So we can go ahead and cancel those two times out. This gives us a constant term here and a constant term here. So we can now combine these two constant terms and we'll get 5.388 is equal to 4.905 meters per second squared times t squared. And then we'll solve for time. So we'll divide through by that coefficient and take a square root. We're only going to keep the positive root because this problem starts at time is equal to 0 and negative time has no physical significance. So we have a root at t is equal to 1.05 seconds. Plug that back in here for our v naught, and then we're able to get a v naught of 12.5 meters per second to clear the wall. With these projectile problems, it's fairly sharp to go back and double check. So I would always recommend when you're solving for two quantities, just go back and plug in both of the two quantities. So plug in the v naught and the t here, and see if you can still calculate this 10 meters. So in this case, when I went back and double checked, I was, and then I plugged everything into this equation and to double check to make sure that it calculated back to 3 meters, and sure enough it did. So this answer of time is equal to 1.05 seconds and v naught is equal to 12.5 meters per second. Double check back in. Thanks for watching. Bye.